These are the indices laws that you need to be aware of. I've broadly grouped them into 6 categories, okay? So the first one, if you have two powers that are multiplied together, so a to the power of b multiplied by a to the power of c, you can combine them into one power by adding them together, so b plus c, like this here. So for example, if you had 2 to the power of 3 multiplied by 2 to the power of 2, you can combine these by writing it as 2 to the power of 3 plus 2. So therefore this is going to be 2 to the power of 5. Now really quick, something that's important. In order to use the indices laws, the bases of the powers have to be the same. The base is the bigger bottom number here. So in this case, both of the bases are a, so we can use the indices law. In this case, both of the bases are 2. If, for example, we had something like 2 to the power of 4 multiplied by 3 to the power of 5, we would not be able to use the indices law here because we have two different bases. Okay, so the second law is if you have a power divided by another power, so for example a to the power of b divided by a to the power of c, remember this can also be represented as a fraction, so it could be a to the power of b over a to the power of c. This is equal to a to the power of b minus c, like this is. So for example, if you had 3 to the power of 3 over 3 like this here, remember when you have this 3 on its own here, this is actually a 3 to the power of 1, so therefore we can use the indices law here and write this as 3 to the power of 3 minus 1, which is 3 to the power of 2. Okay, the third indices law is if you have a to the power of b and all of this is to the power of c, you can multiply the b and the c together, so it's a to the power of b times c, which is obviously a to the power of BC. We can write it like this as well. So for example, let's say that we had 5 to the power of 3 and all of this was to the power of 2. This is equal to 5 to the power of 3 times 2, which is 5 to the power of 6. Something else I just want to mention in this law as well, if you have two things inside a power, so for example, if you had a b and both of these terms are to the power of c, you raise both of the terms to the power of c, so this is going to be equal to a to the power of c, b to the power of c, like this here. So for example, if you had something like 2x to the power of 2, you raise the 2 and the x to the power of 2, so 2 to the power of 2 is 4, and then x squared, like this here. The fourth law is if you have a to the power of a half, this is equal to the square root of a. So for example, if you had 2 to the power of a half, this is equal to the square root of 2. Likewise, if you have a to the power of 1 over 3, this is equal to the cube root of a. Now, more generally, we can expand this and we can say that a to the power of 1 over c is equal to the c root, if you like, of a, like this here, and this is generally how it works. Okay, now this could get a bit more complex, so rather than having 1 here, this could also be another number. So for example, if we had a to the power of b over c, like this here, what would this be? Okay, so we still have this c here in kind of the denominator of the fraction in the power, so it's still going to be the c root of a, like this here, and then this b in the numerator of the fraction, we're essentially going to raise everything to the power of b, like this here. So for example, let's say that we had 3 to the power of 2 over 3. Okay, so what this would be, so we have this 3 in the denominator here in the fraction, so it's going to be the cube root of 3, and then we have this 2 here, so everything here we're going to raise to the power of 2. So this is what 3 to the power of 2 over 3 means. Okay, so the fifth law is if you have a to the power of minus 1, this is equal to 1 divided by a, or you can also write this as a fraction, you can write this as 1 over a, like this here. So for example, let's say that you had 2 to the power of minus 1, this is going to be equal to 1 over 2, like this here, which is a half. I just want to show specifically what happens if you have a fraction in this case. So let's say that we had 2 over 3 to the power of minus 1. So this is going to be 1 divided by 2 over 3. Remember, when you divide by a fraction, you can flip the fraction. So 1 divided by 2 over 3 is equal to 1 multiplied by 3 over 2. We flip the fraction here, and then 1 times 3 over 2 is equal to 3 over 2. So when you do a fraction to the power of minus 1, it flips the fraction like this here. Let's say it's not to the power of minus 1. Let's say that we have a to the power of minus b instead, okay? This is going to be equal to, so we still have the minus here, so this is going to be 1 over a, like this here, and then this b here, this a, is going to be to the power of b. So for example, let's say that we had 2 to the power of minus 3, okay? So this is equal to, so we have this minus here, so it's going to be 1 over this 2, and then we have this 3 here, so this is going to be 2 to the power of 3, and 2 to the power of 3 is 8, so this is 1 over 8. So 2 to the power of minus 3 is equal to 1 over 8. Where this can get a bit complicated is when we have both a negative and a fraction power. So for example, if we have 4 to the power of minus 3 over 2. The way that I would advise you to approach this is just to take it slowly and step by step, okay? So we have this minus here, so this means this is going to be 1 over 4 like this here, and we have this 3 over 2 here. This is the equivalent of the b here in this a to the power of minus b, so this is now going to be the power of a, so this is now going to be the power of 4, this 3 over 2 like this here. Now this is still going to be 1 over 4. Now remember what 3 over 2 means as a power, so this 2 here in the denominator, this means that we square root it, so we're going to square root 4, and then this 3 here means we're going to raise everything here to the power of 3. Okay, so we can simplify this, so this is going to be 1 over, and then the square root of 4 is 2, and then this is to the power of 3, and then 2 to the power of 3 is 8, so this is 1 over 8 like this here. So 4 to the power of minus 3 over 2 is equal to 1 over 8. Okay, and then the sixth law is a to the power of 0 is equal to 1. Anything to the power of 0 is equal to 1. So 2 to the power of 0 is equal to 1. 1,000 to the power of 0 is equal to 1. 7 to the power of 0 is equal to 1. Any number to the power of 0 is equal to 1. Now, I remember when I started learning indices law, I thought this was quite weird, because if you think about this, like, so let's take, for example, 2 to the power of 3. If you think about this, like, there are 3 2's multiplied together, so 2 times 2 times 2, so therefore 2 squared is 2 2's times together, so 2 times 2, and then 2 to the power of 1 is 1 2. So you would naturally think that 2 to the power of 0 is kind of 0 2's, so therefore it would be equal to 0, but this isn't the case. 2 to the power of 0 is equal to 1. Anything to the power of 0 is equal to 1. I'm not going to explain why here, because you don't need to know it for A level. You can just memorize it if you want. If you are interested into why, there's a really good video by Eddie Wu in which he talks about why anything to the power of 0 is equal to 1, if you are interested at all for why it's the case. One other thing that I want to mention quickly that comes up so often in exam questions is something like this here, where we have 25 to the power of 2 over 5 to the power of 2, okay? Now, we cannot use any indices laws on this here because we have two different bases. Here we have a base of 25, and here we have a base of 5. But remember that 25 is equal to 5 squared. So what we can do is we can rewrite this 25 here as 5 to the power of 2, and then this 25 here is to the power of 2, so it's going to be 5 to the power of 2 to the power of 2 like this here. Replace the 25 with the 5 to the power of 2, and this is over 5 squared like this here. If you remember your indices law, we have this 5 to the power of 2 and all of this to the power of 2, so it's going to be 2 times 2 as the power here, so it's going to be 5 to the power of 4 over 5 to the power of 2, and then here this is going to be 5 to the power of 4 minus 2, which is 2, like this here. So this is the way that you can simplify this. This is a really common thing they ask in exam questions, where you need to rewrite the base. Okay, so here's a past exam question where we need to express 9 to the power of 3x plus 1 in the form 3y, okay, and this is for 2 marks, okay? So we have this 9 base here, and we need this to be a 3 base, okay? Now remember that 9 is equal to 3 squared. So this 9 to the power of 3x plus 1, we can rewrite this here. Instead of the 9, we can say it's 3 squared, like this here. Then this is to the power of 3x plus 1. Remember your indices law. If you have 3 to the power of 2 to the power of 3x plus 1, you can multiply the 2 and the 3x plus 1 together. So this is 3 to the power of 2 multiplied by 3x plus 1, and then this is equal to, if you expand this bracket here, it's going to be 3, and then 2 times 3x is going to be 6x, and 2 times 1 is 2, and this is in this format here, 3 to the power of y, where y is equal to 6x plus 2. Okay, so here's another past exam question where for part A we need to write down the value of 32 to the power of 1 over 5. Okay, so remember what the power of 1 over 5 is. So we have this 32, and when you have the power of 1 over 5, this is going to be the 5th root. And if you figure this out, or just put it into your calculator, this is equal to 2. And then for part B, we need to simplify fully 32x to the power of 5 minus 2 over 5. Now remember the indices law that I talked about. If you have two things in a bracket, so this 32 and this x to the power of 5, you need to raise both of these to the power of the minus 2 over 5, okay? So this is going to be 32 to the power of minus 2 over 5, and then this x to the power of 5 to the power of minus 2 over 5, like this here. Okay, so this is going to be equal to, so remember when you have like a negative fraction like this here as the power, just do it step by step. So we have this minus in the power here, so this is therefore going to be 1 over 32, and then this is going to be to the power of this 2 over 5, and then we have this x to the power of 5 to the power of minus 2 over 5. Now remember, when you have a power to a power, you can multiply them together, so we have 5 times minus 2 over 5, and this 5 will cancel out with this 5 denominator to just leave us with minus 2. So therefore this is now going to be x to the power of minus 2, like this here. So we have this 1 over 32 to the power of 2 over 5. Now remember what this means. So we have 32. When you have this 5 in the denominator like this here in the power, this is going to be the 5th root, and then we have this 2 here, so all of this is going to be to the power of 2. We're still going to have this x to the power of minus 2 like this here, and this is equal to, so we have the 5th root of 32, which as we figured out in part A is equal to 2, so this is going to be 1 over 2, and then we have this power of 2 here, and then x to the power of minus 2, then this is equal to, and then 2 squared is 4, so this is going to be 1 over 4 x to the power of minus 2. You can leave the answer like this, they accept this in the mark scheme. However, what you could also do to simplify it is you could say 1 over 4, and remember x to the power of minus 2 is going to be equal to 1 over x to the power of 2, like this here, and we have this 1 over 4 multiplied by 1 over x squared, which we can write as 1 over 4 x squared, like this here. So you can give one of these two here as your final answer. Okay, so this here is a bit more of a difficult question, okay? So we're given that 9 to the power of x minus 1 over 3 to the power of y plus 2 is equal to 81, and we need to express y in terms of x for 3 marks. Okay, now when it says express y in terms of x, this just essentially means make y the subject, okay? So we have this 9 base here and this 3 base here, so in order to use any indices laws, we need these bases to be the same. Now remember that 9 is equal to 3 squared. So what we can do is we can stub this in and say this 9 to the power of x minus 1, instead of 9, we can say that this is 3 squared, and then this is to the power of x minus 1, and this is over this 3 to the power of y plus 2, and this is equal to 81. Now remember, when you have this 3 to the power of 2 and all of this to the power of x minus 1, you can multiply the 2 and the x minus 1. So this is going to be 3 to the power of 2 multiplied by x minus 1 over 3 to the power of y plus 2, and this is equal to 81. And we can expand this bracket up here, this 2 times x minus 1. So this is going to be 3 to the power of 2x minus 2 over 3 to the power of y plus 2 is equal to 81. Now here we have this 3 to the power of 2x minus 2 divided by 3 to the power of y plus 2. So what we can do, we can use our indices law here and write this as 3 to the power of 2x minus 2 minus this power here, this y plus 2, and this is equal to 81. It's really important here to remember to put brackets around the y plus 2 because we're minusing this entire thing. You need to put brackets around the y plus 2, and then if we do this, it's going to be 3 to the power of 2x minus 2, and then we have this minus bracket y plus 2. So if we expand this here, it's going to be minus y minus 2 is equal to 81. This is why it's really important to put brackets around this y plus 2, because we need to have this as minus 2 here. Then this is 3 to the power of 2x minus y, and then minus 2 is minus 4, and this is equal to 81. So we have 81 here, and remember 81 is actually equal to 3 to the power of 4. So what we can say is that 3 to the power of 2x minus y minus 4 is equal to 3 to the power of 4. Now here we have 3 to the power of this is equal to 3 to the power of this. So therefore these powers here are actually going to be equal to each other. So we can say that 2x minus y minus 4 is equal to this power here, which is 4. So what we've just done, because 3 to the power of this is equal to 3 to the power of this means that these powers are going to be equal to each other, so we can set up this equation here. You can essentially think about this like the 3's are being cancelled out here to just leave us with this equation here. We need to make y the subject. Let's move this 4 to the other side, so it becomes 2x minus y, and then we have this minus 4, and then it's going to be minus 4, which is minus 8 is equal to 0. Then move this minus y to the other side, so we get that y is equal to 2x minus 8, which is the final answer. So y is equal to 2x minus 8.